Thank you everyone for coming. My name is Sumit Kapoor, and I was hoping that I don't end up having a conversation with Siri myself, so thanks everyone for coming. And incidentally, my daughter's name is Siri, so it wouldn't be that bad of a thing. I do it daily. But let's take a look at what APIs are doing for AI. So just to introduce myself and my company, I'm Sumit Kapoor. I've been at IBM for the last 10 years or so. I just left IBM about last year. I was managing the IBM Partner Marketplace platform, and I'm a co-founder of Zorang with my partner in crime, Anurag, who's over here as well. We are a company based out of the Bay Area, and we are focusing on the ECM space, enterprise content management and e-commerce, along with integration. And the reason is that we are focusing on the best of breed solutions in the ECM space. And when you have all these best of breed solutions, you need an integration layer to connect them, and especially in the context of e-commerce. So an ECM, just to give you an overview, consists of multiple different layers. Content management being web content management, could be digital asset management, product information management, product content management, and document management. So all of this data that you collect in these systems feeds e-commerce, which could be Magento, Hybris, Demandware, etc. And then to integrate these best-of-breed systems together, you need integration. And then also I'm going to touch on the context of AI in the space, where AI solutions how these AI solutions are transforming the business. We cater to mid-sized to Fortune 500 companies. We also build mobile applications. One of our applications out there in the market is Shop Jester. You can check it out. We have partnerships with companies like Acquia, Akinio, Bloomreach, IBM, Jitterbit, etc. And we also have expertise in SAP Hybris and Magento. So let's take a look at a quick history of APIs. I don't want to be preachy about that. I think everyone is familiar with that. That's why you're here in this conference. So APIs have been around for not that long in the context of computers, right? Initially as libraries for remote procedure calls and using interface definition languages for defining these. These IDLs were machine specific, so they were essentially the issue was that once you wrote them for a specific platform, you couldn't port it over to another. So from there they evolved into the SOA architecture that we saw in the 90s, where a lot of enterprise deployed SOA architecture and using SOA-based web services. WSDLs, XML was a foundation for all these web services. But what we discovered was it was really heavy. So some of the issues around SOA architecture was scalability. It was expensive to deploy. Everyone in the organization had to buy in, so to expose their services as in the SOA architecture. So, and it was heavy. XML by nature is heavy. So it was not very, from a performance point of view also, you hit a lot of bottlenecks. So in the 2000s, we saw the evolution of REST and JSON, and which was lightweight, which was addressed, which basically came around to address all of these issues with SOA. And it was really good. It addressed a lot of these issues. It was lightweight, easy to scale. You could provide different services. You can even build, as we are seeing today, microservices around these. And you can, but then it also introduced some issues, like there were too many services, like service endpoints, like URIs, and they were all independent, right? So you didn't know which ones to access for which service. So now we're seeing an evolution in that space to GraphQL, which allows you to access all of these services through a single endpoint, single interface. We also have serverless API framework that is coming out using AWS Lambda. We ourselves are using it internally for a simple use case I can share with you is, so all our AWS instances that are running in the cloud, we use the Lambda infrastructure to actually take snapshots of those instances automatically. So it's a Python script running in the Lambda infrastructure that AWS provides, and they bill us only when we use the service. So every time it runs on a weekend or something to take a snapshot, we get charged only for that short time period when it runs. You don't have to worry about deployment. You don't have to worry about scaling. If I put resource-intensive APIs over there, Amazon will take care of scaling the infrastructure for you. So this is some cool stuff that is happening over there. I also wanted to mention service registries, which have been around for a while, like WSRR. And today we see Swagger Hub for REST interfaces. We have API management applications like IBM API Connect and others. They provide kind of a repository for all of these APIs and allows you to govern and manage them. So, and the reason why I'm mentioning them over here is important in the context of when I'll talk about AI and which direction we are moving in. So now let's take a look at the history of AI. So I don't know if it is a surprise for you, but like in Greek mythology, we actually see Aristotle has some references to syllogistic logic, which basically is a deductive way reasoning, a deductive way of coming to a conclusion. So that two separate systems could actually use this algorithm to actually come to the same conclusion. John McCarthy, who we credit for artificial intelligence, the name, itself coined the term in 1956. So, and then, so if you see, artificial intelligence has been around for a while. And the last 2 decades has seen a tremendous increase in AI capabilities and services. And today the buzzwords are around autonomous vehicles. Stanley actually won the DARPA Grand Challenge way back in 2005, in today's terms. So again, some of the self-driving cars technology has been around for some time now. And still we don't see them, we are just beginning to see them in our hands. We have smarter assistants, I don't have to mention that, Alexa, Cortana, Google Assistant, Siri, etc. And then we have smart connected devices which use machine learning technologies to actually learn your behavior, and like Nest thermostat, which actually starts up the AC or HVAC system based on your habits when you're in the house and when you're around. We see a lot of these applications in the healthcare diagnosis space as well, like using machine vision capabilities to recognize, say, if you have a skin condition or something, you can use machine vision to actually analyze it and make a preliminary diagnosis before it even goes to the doctor. We also have analytical ability around taking all these records, huge amounts of records that are there in the healthcare space, and making diagnosis based on symptoms for a patient. So there's a lot of research and applications going on around the healthcare space. And there are cognitive systems, which is essentially systems which have the ability to interact with humans, like natural language processing capabilities and tone recognition, being able to analyze the sentiment of the person, etc. as well. So we're seeing a lot of stuff happening in the AI in the last, and especially it has picked up a lot of steam in the last 5 years or so. And so what does this tell us? So it tells us, like, from the time immemorial or way back, we have been trying to invent things that can do our job for us. So by nature, humans are always looking to take the easy route, right? When I was at school, we were working on on AI stuff, like machine vision stuff, where we specifically one project that I worked on was taking a sequential set of 2D images and converting them into a 3D model. which you see now today with like if you go to Google Maps, you can actually see 3D models of that. They are all based on satellite images of which are taken in 2D. So we're seeing a lot of those applications coming live, and that is happening because of the convergence of all of the machine or like hardware capabilities that are available now, plus our better understanding of how a human brain works. So all of that, those technologies are coming together, and these hardware systems are now available in the cloud, so they have really democratized access to these systems. So that is one of the reasons why we are seeing a resurgence in AI space. You have all of this paired hardware capability which you now can apply to these complex solutions. Okay. So let's take a quick look at some of the terminology that is used in the AI space. So artificial intelligence is a broad term. Like you could argue that a computer is artificially intelligent. Like it does the work that you program it to do, right? So it's a pretty broad term. Machine vision is now starts focusing on AI stuff related to analyzing visual, like images, videos, etc. I just gave you an example of extracting 3D models out of 2D images, but then there's object recognition. You can recognize a person in a set of pictures. You can recognize cars. You can even track them, etc. So machine vision is related to that. Machine learning is essentially systems which allow, or algorithms which allow machines to learn autonomously. So you basically just program them once, and then you just feed them data. And then they automatically infer information out of that data set and make valuable insights into that. Now, cognitive systems is a relatively new buzzword that is around. And of course, cognitive itself as a term has been around for a while. But cognitive systems are systems which allow you to interact with humans, like human-like interaction capabilities like voice, speech recognition, text-to-speech, speech-to-text, etc. So, and all of these smart assistants now leverage these capabilities that are available. Some of these systems are, IBM Watson also has these capabilities, Alexa, Cortana, Siri, all of them have it as well. And they use natural language processing to interact with you and me. Now, the last one, the self-awareness, is a very interesting space. So self-awareness is probably one of the most human of traits, and it's very difficult to replicate in a machine. We understand our position in this world, right? And we understand how we interact with our family, how we interact with our friends, and how we interact with our business life with people. We take all of this information. This actually, self-awareness, gives us the ability to make reasoning judgments, right? And we can do really good things with it, and we can do really bad things with this capability. This is where actually all this argument between Mark Zuckerberg and Elon Musk is happening, because this ability for machines, when machines start becoming aware of their capabilities and their position in this world, they can make judgments and reasoning which would be applicable to them. And the fear is that they actually would start making judgments for self-preservation. And that's where this argument between Elon Musk and Mark Zuckerberg took place, and we see still going on Twitter or Facebook, etc. So this is a very cool space, and I have a demo or a video thanks to Rensselaer AI and Reasoning Labs research, which actually shows one of the first times that a robot actually was able to reason, and based on the other robots, actually, you'll see. So these robots were given the 3 wise men test, an equivalent of a 3 wise men test. So I don't know if you're familiar with the 3 wise men test. It's basically a king brings the smartest 3 people in his kingdom and tells them that I'm going to put a hat on your head, and you have to guess which color hat you're wearing. There are blue hats and there are white hats, but then I'll make the test be equal for all of you. So no one will have an advantage. So it's a similar kind of a test for these robots, where they have been told that they're going to be given pills, or an equivalent of a pill, like which is a pad on the head. There are 5 pills, out of which at least 3 are, so 3 of the pills actually make them mute, so they cannot talk after that. And 2 of the pills actually are just placebos, so they are not affected. So let's take a look at, it's very interesting how these robots actually react. I don't have mic cable, so I'll bring my mic close. Oops, that's not what I want. I think we all need one right now, probably. Sorry about that. Okay. So that's giving them a pill. That's equivalent of that.
Which pill did you receive?
I don't know. Sorry, I know now. I was able to prove that I was not given the Zorang pill.
So it's a simple test, but so that robot was able to stand up, make a comment about it, and be able to hear himself back and make a reasoning out of it that it was not given the dumbing pill. And it also knew that because the other robots were not speaking, they probably got the dumbing pill. So that's why it stood up and made the comment in the first place. So it was able to, but this particular test was of course a box test for a specific use case. But we are getting to a place where these robots are now able to sense their place in this world and be able to make reasonable amounts of judgment based on their interaction with everything around them. So which is very cool. And scary at the same time, of course. So let's take a look at some of the APIs that are available out there around in the AI space. Actually, in this modern resurgence of AI, there has been a democratization of AI capabilities. So there are a lot of these service providers which are actually providing these services in the cloud. One of the main issues when we were building these machine learning systems or machine vision systems was that we had to let the system run overnight and come back next day to see the results. And that's not a very good way to interact with these systems, like from a human point of view. Humans are by nature not very patient, right? So, but now with the capabilities of the hardware and being able to make them available in the cloud and being able to access them really through APIs, we have been able to now democratize access to AI technologies. And a lot of companies are building these technologies into their apps. And in fact, enterprises are also starting to look into using these technologies into their enterprise systems, custom systems as well. So some of these common APIs that are available out there are related to, in real time, for voice, images, videos, text, positioning data for vehicles and cars and devices. Intent. The intent is very important. What exactly do you want to do? So those kind of APIs. Then we have non-blocking or batch APIs available as well. None of these systems would actually work without actually giving them training data, right? So we have we saw a resurgence and like maybe 10 years back about big data and Hadoop and all of that. What that really gave us was the ability to take this huge amount of data and be able to access it. But to be able to make sense out of that data, we need to feed that data to these AI systems. So we have these non-blocking batch APIs which can take this huge amount of data that we have now the ability to access and then make analytical reasoning and AI, using AI algorithms on that data. So we are seeing that, and then once we have this analysis, then we have access to that information through these APIs as well. So let's take a look at some of these APIs that are available out there. So let's take a look at the Watson APIs. So So these are primarily targeted to enterprises. We have language APIs. We have, you can extract semantic contextual information from this huge amount of data that you feed to the system. You can use natural language processing capabilities to extract information about the author of the article, be able to analyze the context of the article, etc., and the topic. You can find out information about companies that are mentioned in those articles. That's, and then also, the more important stuff is be able to identify relationships between those companies or even people that are mentioned in those articles. So we have the language API for that. We have speech API, which is fairly common out there, which is now speech to text or text to speech. But we have multilingual support in there. You can also use, leverage the language processing capabilities by using this as the interface for humans to interact with these systems. Then, of course, then we have the vision capabilities where you can recognize objects and you can recognize faces in a suite of images, pictures. Then we have data insights APIs, which allow you to query news data from sites, for example. You can identify patterns, you can trends, and create actionable query insights into this data, and then maybe even take action on that data. So using decision trees. The decision tree APIs have been deprecated, but you can still build those decision tree or intent using intent capabilities in the API. Some interesting new developments that IBM has just released is the tone analysis. Be able to analyze the sentiment of people in those that are interacting with these systems, or even analyzing the sentiment of people on Twitter or Facebook, and that's very important. And I'll touch on the context of that in some of the use cases that I'll talk about later on. Anyone recognize this? So this is, of course, Tippy from that Microsoft built into their Office suite in 1997, and much maligned, of course. So, but this was maybe one of the first few smart assistants out there. And credit to Microsoft to try to introduce it over there at that time. Of course, it was very annoying because it kept popping up when you were trying to do some of your work. So now, of course, with the latest technologies and all, these smart assistants are non-invasive, and you can actually have a conversation with your Siri when you want it to have a conversation, and not have it bothering you all the time. However, they're still listening. So let's take a look at some of the smart assistant APIs that are available out there. So there's voice recognition capability that forms a core of these APIs. There's some natural language processing, but it's still a lot to be desired over there. You can still ask a few questions to Siri or Alexa and get some funny responses back. So it's really, it doesn't do a very good job of analyzing what is the context and what is the intent. You can integrate with these services to provide voice recognition for your applications. So let's take a look at Alexa API. So there's a voice enablement API. There is this API generally allows you then to access all the Amazon backend services and capabilities like music playback capability, timers and alarms, package tracking, etc., etc. So there are a lot more capabilities that you can access through this voice enablement. You can also access capabilities from custom skills that you develop. So that brings us to the skills kit that is available for Alexa, which allows you to build your own custom skills. Like, for example, in my house, I use Alexa to control the lights, for example. It's integrated into a smart hub, which controls the lights, and then I can just tell Alexa to switch on a particular light or switch off another light. It can also track based on, it's connected to a camera, so it can see when a person is walking in, and then based on that, switch on the light. So you can do some cool stuff with it, but still, it's fun to work with. It's still not reached its potential. So you can then, using the skill kit, you can also integrate with other Echo products, like what we are seeing with the Amazon Echo, their video capabilities that are coming around, and the which allows you to actually interface with or overlay information and or use augmented reality capabilities into your apps. So you're seeing that as well. It has multi-language support, which is of course critical because Amazon is all over the world. So you have a lot of capabilities around Alexa. A common theme that you are noticing is that a lot of these AI capabilities are dependent on APIs and the use of their APIs, that we are applying these APIs to our use cases. Let's take a quick look at the Cortana APIs. So again, there is a skills kit which allows you to extend and create your own applications and extend the Cortana platform. It also allows you to access Microsoft Core capabilities. And then also provide voice recognition capabilities. So very, very similar. The Google Assistant APIs also have that OK Google API set, which again allows you to extend the Google API, Google Assistant. And there's a GRPC, Google RPC capability. And they also have, what is this, a little bit different is they have a streaming voice API. So it can actually, you can use the streaming voice API to send real live data, and in real, you can have actually there is a Google Translate capability where you can actually speak into the Google Translate, and in real time it will translate it and play back the audio. So you can be having a conversation with anyone from the other part of the world in their language without breaking a sweat. So very cool capabilities out there. Then we have Siri APIs. Again, Siri Kit again allows you to extend. They also have the intent capability, which allows you to identify what you want to do with the data. So you can, the recognition part comes from the platform. Like you can speak to it, and then when you speak to Siri, it recognizes your information and it tries to analyze what you really want to do, and then you can configure it to using the Intents API and the UI that they make available to actually take some action. So that's available. And then you also, of course, have access to all the capabilities that Siri provides and the Maps capability on the platform as well. Of course, no AI conversation really can be complete without talking about smart cars, which is kind of the latest buzz around it. So there's a lot of buzz around smart cars and self-driving cars. I showed you earlier on that these cars have been actually, the technology has been around since 2005. It has been proven in real world through the DARPA challenge, right? There are two camps right now. Like you can see, there's a pure vision camp, which is like Tesla, and then there is an assisted vision plan, which is using radar, LiDAR, etc. But what the Department of Transportation is pushing is for vehicle-to-vehicle communication using the 5G network capabilities. This is intended to revolutionize the way cars drive themselves on the roads. However, this cannot be achieved unless every car is communicating. So this is still a ways off, but the ultimate goal is that these autonomous vehicles will actually be communicating with each other, and before a car comes to an intersection, it will be able to tell all the other cars in the intersection that its intention is to turn right or go straight, so that there are no accidents. So that's the ideal condition. But again, like all of these technologies can only be possible if you have APIs which gives access to the information. There has to be a broker which allows them to communicate to each other, and it has to be lightweight. But at the same time, it has to be secure also, right? So we have seen CBS 60 Minutes news articles where they were able to control cars remotely without actually even having been, like they just got access to the VIN number of the car, and they were able to access and even make it drive by themselves remotely. So which is very scary. So these networks have to be really secure at the same time while they have to be lightweight and very responsive. So that's where the IoT conversation comes into place, because MQTT is kind of designed to address that to a certain extent. It's lightweight, it has a small footprint, it's built for unreliable networks, so if the communication breaks, the message still gets across. And a lot of these apps are using it. Like you might be surprised to see a Facebook Messenger, IBM message site has the support for MQTT, Amazon IoT is using it, Microsoft Azure is using it, etc. So MQTT is definitely there, and it's being adopted by a lot of these platform and services providers. So then I also want to mention about AI-based analytics and capabilities, because I think that's where with the enterprise use cases lie, because you can actually take all of these huge amounts of data and then use these AI technologies, machine learning technologies to make and natural language processing capabilities to analyze that data and take preemptive action. So for example, all of these IoT devices inside now jetliners, and you might have seen GE ads on television, they basically are talking about all of these different components within an aircraft talking to each other and to a hub and giving information about their status. And then they can actually, based on the parameters or the analytical information that they gather from all of these devices, they can make a judgment call on when a particular component might fail before it fails. So you can take preemptive action using these APIs, using these systems. And machine vision and machine learning are playing critical roles over here, right? So I don't want to go back to, but all of these, what I discussed over here, actually you can see machine vision and machine learning capabilities being leveraged. So let's take a look at some of the use cases. So one of the use cases that is close to our hearts at Zorang is content management, right? And I talked a little bit about what exactly is enterprise content management. So there are multiple layers. I talked about that. I talked about the different components of content management. One interesting fact about content management is there's huge amounts of unstructured data out there. All these web pages, etc., that you see, billions and billions of pages out there, and you just add millions of pages on a daily basis. All of that data is unstructured content. And it's messy. It's huge amounts of data. Hadoop allows us to access and retrieve the information from there. But then how do you catalog, how do you categorize this data? And AI has the ability to actually transform the space completely. So, and that's why what we are betting on. And I think we can leverage all of these AI capabilities that are now available through Watson and other service providers to good effect over here. You can use the natural language processing capabilities to analyze the data, catalog it, categorize it. So we can help our enterprise customers with that. So AI capabilities are a great fit in this space. Let's take a look at another use case. So e-commerce. So e-commerce, a lot of companies are under a tremendous amount of pressure from Amazon, and the likes of Amazon and Walmart. So we see that Amazon has an app for you. The e-commerce, like Walmart, has an app for you too. So the space is very fragmented. How many apps can you really have on your device? So you need to differentiate yourself. And the only way you can differentiate yourself today is by either devoting tremendous amount of people resources or using these AI capabilities. So I think you can do advanced personalization that can analyze the habits and buying history. They can analyze the sentiment of the person. Like, hey, I'm here on the website, I'm looking for something to go to a wedding, for example. And then present you with the dresses which are appropriate for weddings. So I'm feeling happy, so I want to shop for something more lively, colorful, or something like that. And only, so I can present the customer products which are more lively and kind of goes with that mood that they are in. So based on this advanced personalization capabilities, we can do product recommendations and you can upsell. We can do dynamic pricing. So you can notice on Amazon, you go today and go on Amazon looking for a product, go an hour later, that same product will be priced differently. So Amazon is implementing dynamic pricing, and it's very smart of them. They are using this machine learning capabilities that, like, especially like you might have, if you use Amazon, you may have a lot of stuff in your cart, right? So they are using that information that you've put all this thing in your cart to analyze when is a good time to drop the product by a few dollars to entice you to buy it. So it's very cool capabilities, but all of this behind the scene, they're using machine learning capabilities to do dynamic pricing. And you want, if you're an e-commerce retailer and all, you want to build it into your platform as well, and we can help you with that. Automatic product configuration. So for example, a good use case could be you're in the market for buying a desktop. Now, a lot of, like Dell allows you to go and select component by component, what would be suitable for you. What about if I go to Dell and say, I want to play this particular game, I want to build a gaming rig, but I want to play this particular game. And based on that information, it is able to configure the best machine for you, right? So those kind of automatic product configurations you can achieve through AI capabilities, machine learning capabilities. Product promotions is another area that we feel that can be affected tremendously by these AI capabilities. You can promote certain products on certain pages, but then depending upon the visitor traffic, change that promotion or the type of demographic that is coming in. I also already talked about product classification and categorization, which is from the previous slide, which is the categorization and classification of information. So that's another place where you can use natural language processing capabilities to automatically classify and categorize your products. Predictive search, facets, those are other capabilities that you can apply. You can use that to analyze the intent of the user. And then, of course, use all of this information that you're gathering and feed it into your AI systems to do a sales analysis and do projections, very accurate projections based on that. Customer support is another area where AI capabilities can be really helpful. With the reduced number of support folks, you can actually serve a lot more customers. And in the next slides, I'm going to talk a little bit about that. With using bots, which could be voice-enabled or it could be chat or text bots. So let's take a look at customer support and service use case. So we see a proliferation of chat and voice bots. In fact, so much so that there are tests that folks have done where customers have not been able to distinguish whether they were talking to AI or they were talking to a real person behind the scenes. And that is, can bring tremendous amount of change to how we serve our customers. We can provide 24/7 service. We can provide service in their language. We can provide, using natural language processing, we can analyze their tone, their sentiment, and then take action based on that. If a customer is upset, and they are a good customer of ours, we can actually direct them straight to a human who can actually then interact with them and address their concerns. We can provide empathy in their using the tone analysis capabilities, which are not possible today, right? If you look at all of these things, like they are very similar to IVR capabilities, right? But it takes IVR to a step further. It's like that IVR, like if an IVR system, when you interact with a bank and all, and you are looking to do something, and then you see, okay, there are 8 options that it reads out to you, and you were looking for the 9th option, which is missing in that menu, right? So the AI gives you the ability to actually take that condition also, the 9th option also, and provide an action based on that. Then also want to talk a little bit, mention about some of the service frameworks that are available that can allow you, that you can leverage to build these capabilities into your platforms. These support a lot of frameworks, including devices like iOS-based, Android, Cordova, JavaScript, etc. So AI.API is there, with.ai is there, which are very easy to integrate into your applications and platforms. Microsoft Bot Framework is there. IBM Bluemix also has bot capabilities, and then Facebook also provides a chatbot capability and all. So a lot of these services are only accessible through those APIs that we talked about a little bit earlier. So APIs is playing a critical role in the success of AI today. And without API, actually, without the democratization of that the cloud has brought and the API capabilities, the AI resurgence that we are seeing today wouldn't be possible. We are just scratching the surface, right? So these are systems are centrally hosted. Today, they are providing the basic building blocks for you. There are rudimentary AI capabilities depending on the platform, how deep they are. And ultimately, at the end of the day, how you train the brain develops a brain too, right? So how much data you feed them. What we are, and the garbage in, garbage out philosophy still applies over here, right? So if you feed in a lot of incorrect information, the AI platform will not make good, efficient inferences out of that, or good analysis of that data. So what direction are we heading into? So I mentioned about WSRR and other repositories that are available out there for Swagger Hub, etc., for APIs. I think what we are seeing is a move towards that direction for API capabilities too. A lot of these API services are available through marketplaces. And these marketplaces allows these services to be discovered. And you can access these services from these platforms and then build in your integration with your app. The customer directly either interacts with these services or they interact with the application, which then interacts with these platforms. So that is going to continue happening. But what will also happen is auto discovery of these services by AI-enabled applications and devices. Where these, like for example, in Alexa, I could basically ask Alexa to download and install a skill kit, which increases its the ability to provide certain new functionality to you. You're going to see that kind of capability come online. You're also going to see convergence of quantum computers. I don't know it's a complete different topic, but I just wanted to mention it over here. Because just like we saw the convergence of hardware capabilities and cloud and AI capabilities, quantum computers have the potential to transform the space completely. This will actually mean that we would have autonomous systems which could actually work with minimal interaction. They will still need to be trained, so APIs are not going to go away. To train them, you still need APIs. They still probably will be communicating with a centrally hosted system. Again, you need APIs and all. But this will actually truly create autonomous systems which don't have to reside in this huge data centers in the cloud. So just to conclude, so as we said, as I mentioned earlier, APIs are central to the evolution of AI. There are a lot of low-hanging fruit today that we can access through these API capabilities that are available for categorizing, cataloging your unstructured content. You can take out actionable intelligence and also take action based on that intelligence. You can leverage these AI capabilities on e-commerce, use them for integration. So there's a lot of low-hanging fruit that can be leveraged for your enterprise application or for your consumer app. Skynet is still a ways off, I think. So as we talked a little bit about self-awareness, we are getting there. Like machines are getting self-aware, as the demo that I showed you. And it's definitely scary, but I think they're still primitive, right? They're contained in a box, like there are specific use cases, etc. We also saw recently a news article about Facebook's AI engines being able to communicate with each other using their own language. It was a little bit overblown, I would say. It was more of a marketing thing. Because if you analyze their language, it was basically machine language, essentially, how a machine would think. You call or maybe a baby on a human scale, a kindergarten, not even kindergarten, a preschooler would talk about things, right? You mention something 5 times, it's like, it means 5 times of that thing. So that was very rudimentary capabilities. But you can also see a lot of AI engines being able to create their own script. That's an easy problem to solve because you can actually infer based on written language, and that's kind of, an English language contains 26 alphabets, right? So you can actually generate, these systems are now capable of generating their own script very easily. So, but Skynet is still a ways off. And there's still a case for humans. I think human interactivity is still there. I think we by nature, we are social animals, right? So we still, even though we might be talking to AI, but at the end of the day, we need to still interact with the other humans and And only a other human can actually empathize as efficiently with us, another human, than a machine could. So the fully automated systems are still ways off. They're all of these technologies that we're seeing today are assisting technologies. They assist us in improving our efficiencies, they assist us in improving our business, and they are able to actually, you can leverage them to increase our revenues. And that's where Zorang comes in. So just to conclude, so we build AI solutions, we build AI capabilities into your enterprise apps. We have integration capabilities which are critical to leveraging these AI capabilities that are available out there. So we have skills in that area. We also do enterprise content management, which again has multiple layers: WCM, PIM, PCM, DAM, digital document management. We do e-commerce and we do also mobile. We are working with the leaders in the spaces, the respective spaces: IBM, Akinio, Jitterbit, Acquia, SAP, Bloom, Reach, Magento are some of the partners that we are working with. And you can reach me at my email address and Anurag at his email address, and follow us on Twitter. So with that, I can take a few questions. I think I have a couple of minutes. Sure.
Do you have any guidance? Let's say that I want to develop something on NLP, right? How do I go about choosing whether to use Cortana or Alexa or any of the service providers or skill kits? Are there any basic guidelines that you would offer?
It primarily depends on the use case that you're trying to go, right? If you're building a consumer app, you of course know that Alexa and Siri are probably the most popular out there, right? And the device that you're targeting as well, the interface. So that is very critical in your selection. If you're building an enterprise app, I would suggest going to Watson, because that has enterprise scale capability, it has security capabilities, etc. as well in there. So it totally depends on the use case that you're. A lot of these platforms are providing similar kind of capabilities as you saw. Voice enablement is there across, it's a common feature. NLP, natural language processing, is a common feature. Intents capability is a common feature. So a lot of them are very similar, but I think it depends on the use case that you're trying to solve in your target audience.
Maybe if I can ask you a follow-up question. The
Sure.
training and the validation data, are there places, are there the GitHub equivalents where we can go, download the training or the validation data? Are there any such?
So as I mentioned, marketplaces give you access to a lot of these APIs. So there's IBM Marketplace, there's Salesforce, there's Microsoft. So these marketplaces give you access to not only the services, but to their documentation information as well. Then of course you can go directly to any of them and find documentation over there as well. So I think that would be the way to go. Any other questions I can address? Great, thank you. Thank you everyone for coming.